You know the derivative of a constant is 0. d by dx of a constant is always 0. d by dx of cos x, derivative of cos x is minus sin x, derivative of tan x is secant square x, first function into differentiation of second function plus second function into differentiation of first function. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, Faculty of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Now in this session today I am going to discuss regarding differentiability, the derivatives of functions. So in previous classes you might have been studied regarding differentiations. So in first PUC you might have been studied regarding differentiations of functions, algebraic function as well as trigonometric functions. Now in this second PUC concepts, you are going to study different different methods of differentiations. So differentiations of function of a functions, then implicit functions, composite functions, parametric equations, and second derivatives. These are the things which you are going to study. So parametric equations, that is differentiations of function of a function, composite functions, then differentiations of implicit functions, parametric functions, then secondary derivatives. These are the things which you are going to study in this session. Now let me discuss, before going to the exact differentiability, let us recall the things which you have studied in first PUC. Now let us list out the formulas which you have studied. So the standard results in differentiation, the formulas which we have studied in first PUC. You know the derivative of a constant is 0. d by dx of a constant is always 0. Derivative of a constant is 0. That is, for example, d by dx of 2. 2 is a constant. Derivative of a constant is 0. And the very important formula which you have studied is d by dx of x to the power of n is nx to the power of n minus 1. Where n is any integer, any rational number. It may be positive integer, negative integer, or a fraction. So d by dx of x to the power of n is equal to nx to the power of n minus 1. For example, let us consider d by dx of x. Now derivative of x. What is d by dx of x? Here you know x is nothing but x to the power of 1. Here x to the power of 1. So what is n here? 1 x to the power of 1 minus 1. 1 x raised to 1 minus 1 is 0. That is 1 into x raised to 0 is 1. That's equal to 1. So derivative of x is equal to 1. d by dx of x is equal to 1. Now if we come to derivative of 2, d by dx of x square, differentiation of x square. What is n here? N is equal to 2, x to the power of 2 minus 1. This is 2x to the power of 2 minus 1 is 1. This is equal to 2x. So derivative of x square is equal to 2x. See here, d by dx of x raised to n is nx to the power of n minus 1. So d by dx of x is nothing but x to the power of 1. N is equal to 1 x raised to 1 minus 1. X raised to 0 is 1. 1 into 1 is 1. Differentiation of x is equal to 1. Similarly, derivative of x square, d by dx of x square. What is n? N is equal to 2. 2x to the power of 2 minus 1. That is 2x raised to 1 is 2x. Similarly, if you come to this d by dx of x cube. What is n here? d by dx of x cube. Here n is equal to 3, x to the power of 3 minus 1. This is 3x to the power of 2. So differentiation of x cube is 3x square. Differentiation of x is 1. Differentiation of x square is 2x. Derivative of x cube is equal to 3x square. Similarly, if you come to this, d by dx of x to the power root x, d by dx of root x, this can be written as d by dx of root x is nothing but x to the power of 1 by 2. What is n here? N is equal to 1 by 2 of x to the power of minus 1. Half into x to the power of, take LCM, 2 is LCM, 1 minus 2. So this is equal to half x raised to minus half into, bring this x raised to minus half to the denominator, this is plus half. So x 1 over 2 into x raised to half can be written as root x. Therefore derivative of root x is 1 over 2 root x. d by dx of root x is equal to 1 over 2 root x. Similarly, d by dx of 1 by x is minus 1 by x square. See here, d by dx of 1 over x can be written as x raised to minus 1. Right. Take this to the numerator. You know law of indices. A to the power of 1 over a raised to m can also be written as a raised to minus m. take this to the numerator. 1 over x can be written as x raised to minus 1. N is equal to minus 1. X to the power of minus 1 is minus 1 x raised to minus 2. Bring this to the denominator. This becomes minus 1 by x square. So d by dx of 1 over x is equal to minus 1 by x square. And you know the derivative of e raised to x is e raised to x itself. It won't changes. D by dx of e to the power of x is e to the power of x itself. So these are the basic formula standard result you might have been studied in your previous class. D by dx of constant, derivative of a constant is 0. D by dx of x is equal to 1. D by dx of x square is equal to 2x. D by dx of x cube is equal to 3x square. And d by dx of x to the power of n, this is very important formula, nx to the power of n minus 1. D by dx of root x is 1 over 2 root x. And d by dx of 1 over x is equal to minus 1 by x square. And d by dx of e to the power of x is equal to e to the power of x. Now let us know a few more formulas. Now this logarithmic differentiations. So what is d by dx of log x? Differentiation of log x is equal to 1 by x. And differentiations of trigonometric functions you might have been studied. D by dx of sin x is equal to cos x, and d by dx of cos x is equal to minus sin x. D by dx of tan x is equal to secant square x, and d by dx of cosecant x is equal to minus cosecant x cot x, and d by dx of cot x is equal to minus cosecant square x, and d by dx of secant x is equal to secant x tan x. Okay, see here what happens here for first three. Sin, this is alternative positive negative d by dx of sin x is cos x is minus sin x. D by dx of tan x is secant square x, and d by dx of cot x is minus cosecant square x. D by dx of secant x is secant x into tan x, and d by dx of cosecant x is minus cosecant x into cot x. So in order plus minus alternative positive negative you are going to get. So these are the differentiations of trigonometric functions. D by dx of sin x is cos x, d by dx of cos x, derivative of cos x is minus sin x, derivative of tan x is secant square x, derivative of cot x is minus cosecant square x, and derivative of secant x is secant x tan x, and derivative of cosecant x is minus cosecant x into cot x, and whereas d by dx of log x to base c is always equal to 1 over x. Now let us come to the few problems, simple problems based on this first formula, d by dx of x to the power of n. Now let me take d by dx of x to the power of 4. What is n here? N is equal to 4x to the power of 4 minus 1. This is 4x cube. Now on the other hand, if I take d by dx of x raised to minus 4, negative. So if x to the power of minus 4 means this n is equal to minus 4 x to the power of minus 4 minus 1. This is minus 4 x raised to minus 5, and minus 4 as it is, bring this x to the power of minus 5 to the denominator. Then this becomes minus 4 divided by x to the power of 5. Suppose if I take a fraction d by dx of x to the power of 1 by 2. What is n here? N is equal to 1 by 2. So 1 by 2 into x to the power of 1 by 2 minus 1, 1 by 2 into x to the power of, let us take 2 as the LCM, 1 minus 2. So 1 by 2 x to the power of minus 1 by 2. Bring this to the denominator, 1 by 2 into x raised to half. If you want, you can put this in the form of 2 into x raised to half is nothing but root x. So d by dx, so this can also be written as d by dx of root x. Okay, d by dx of root x is also equal to 1 over 2 root x. Now if I take a fraction, let us take negative fractions. Suppose if it is like this, d by dx of x to the power of minus 1 by 2. What is n here? N is equal to minus 1 by 2 x raised to minus 1 by 2 minus 1. This is minus 1 over 2 x raised to, take LCM, 2 is the LCM, minus 1 minus 2, minus 1 over 2 x raised to minus 3 by 2. Bring this to the denominator, minus 1 over 2 into, this becomes x to the power of 3 by 2. Minus 1 by 2 x to the power of 3 by 2. Suppose if it is like this, d by dx of 1 over x to the power of 4 by 3. Now just take this to the numerator. This can be written as d by dx of x to the power of, whenever this is taken to the numerator, it becomes minus 4 by 3. What is n here? N is equal to minus 4 by 3 x to the power of minus 4 by 3 minus 1. This is minus 4 by 3 x to the power of, take LCM, 3 is the LCM, minus 4 minus 3. This is minus 4 by 3 x to the power of minus 7 by 3. Or if you want, you can bring this to the denominator, minus 4 divided by 3 into x to the power of minus 7 by 3 can be written as plus 7 by 3. Okay, suppose if it is like this, d by dx of cube root of x. Cube root of x. So cube root, fourth root, fifth root, this can be written as d by dx of cube root means x to the power of 1 by 3. Fourth root means x to the power of 1 by 4. Fifth root means x to the power of 1 by 5. So therefore, what is n here? N is equal to 1 over 3, x to the power of 1 by 3 minus 1, 1 over 3, x to the power of, take LCM, 3 is the LCM, 1 minus 3. So this is 1 over 3, x to the power of minus 2 by 3. Bring this to the denominator, 1 over 3 into, this becomes x to the power of 2 by 3. Okay. These are the few concepts which we have studied in our previous classes. So this is very important. Once if you know these basics, then it is very easy for you to solve the problems. Now, let us come to few more rules are there. Now, let us come to the rules, that is product rule and quotient rule. I will take product rule. Let me rub this. Now, let us come to the product rule. Product rule. Before going to the product rule, let us know regarding the rules of differentiations. So, you might have been studied d by dx of, these are the rules, d by dx of constant into function means just constant is kept and differentiate the function, d by dx of the function, where k is a constant. Now, suppose if it is like this, d by dx of f of x plus or minus g of x, then term by term differentiation. So, this is d by dx of f of x plus or minus d by dx of g of x. So, this is term by term differentiation. D by dx of constant into function means constant is kept out, differentiate the function. And if it is d by dx of f of x plus or minus g of x is there means term by term differentiation, d by dx of f of x plus or minus d by dx of g of x. Suppose if there are product of two functions, d by dx of f of x into g of x, or quotient function d by dx of f of x divided by g of x. So then we are going to apply the product rule. What is the product rule? D by dx of u into v. So here u is the first function, v is the second function. First function u constant, derivative of second function, plus second function constant, derivative of the first function. This is called your product rule. First function into differentiation of second function plus second function into differentiation of first function. Or you can also write like this, d by dx of first function into second function. So here first function constant into d by dx of second function plus second function constant d by dx of first function. Okay, this is the rule. First function into derivative of second function plus second function into derivative of first function. That is u into first function constant, first function, second function, u constant dv by dx plus v constant du by dx. So you might have been studied this. Let me take one example on this. I will take one example. Now, d by dx of uv is equal to u into dv by dx plus v into du by dx. Now let us take small example. D by dx of x square into sin x, right? X square into sin x. Here this is first function and second function u and v. What is the formula? X square into first function into d by dx of second function plus second function into d by dx of first function. So this is x square into, what is differentiation of sin x? Cos x plus sin x into differentiation of x square is 2x. So the simplified answer d by dx of x square sin x is x square cos x plus 2x into sin x or sin x into 2x. Similarly, if I take this, let us consider if y is equal to root x and e to the power of x. Now how to differentiate this? So dy by dx, derivative of this is d by dx of root x into e to the power of x. This is first function, and second function, same product rule. First function constant, root x constant, d by dx of second function plus second function constant, d by dx of root x. Okay, first function into derivative of second function plus second function into derivative of first function. Wherever there is d by dx, differentiate. So root x as it is, and you know derivative of e to the power of x is e to the power of x plus e raised to x into derivative of root x is 1 over 2 root x. You can remove the common factor, e power x common factor, root x plus 1 over 2 root x. If you want, you can take LCM and also simplify. This is how we are going to use the product rule. Okay, this is regarding the product rule is concerned. Product rule is d by dx of uv is equal to u into dv by dx plus v into du by dx. Now let us come to the quotient rule. What is the quotient rule? The quotient rule. So if it is numerator divided by denominator, d by dx of u by v. d by dx of u by v can be written as v into denominator into d by dx of numerator du by dx minus numerator into derivative of denominator dv by dx divided by v square. This is the formula. This is quotient rule, or this can also be written like this: d by dx of numerator divided by denominator. NR means numerator divided by denominator. So this is equal to denominator first constant, denominator into differentiation of numerator minus numerator into d by dx of denominator divided by denominator square. Okay, so u by v means v into du by dx minus u into dv by dx divided by v square, or it can also be remembered like numerator divided by denominator. d by dx of numerator by denominator means first denominator constant, denominator into differentiation of numerator minus numerator constant, d by dx of denominator divided by denominator square. This is regarding the quotient rule. Let us take one small example. Now d by dx of x divided by sin x. Now this is of the form u by v. Okay, what is numerator? X. What is denominator? Sin x. Denominator constant, sin x constant, d by dx of numerator, right, minus numerator constant, d by dx of denominator divided by denominator square. Okay, now wherever d by dx, differentiate there. So sin x into differentiation of x is 1 minus x into, differentiation of sin x is cos x divided by sin x whole the square. So this can also be written as sin x into 1 is sin x minus x cos x divided by sin x whole square, or you can also write sin square x, sin x whole square or sin square x. This is how we are going to differentiate using quotient rule. Okay, these are the few basic concepts regarding the derivatives which you might have been studied in your first PUC. Now let us come to the exact definition of a differentiability. Now let us consider a function f. If a function f is differentiable at a point C, if a function f is differentiable at a point C, then it is continuous at that point. If a function is differentiable means then it is continuous at that point, but the converse need not be true. It may be true or may not be true. So, but a function f is differentiable means then it is continuous at that point C. Now, you know the definition of a function using first principles method or by definition method. What is our definition method we are going to use for this? So, let us consider if f of x is a function, given that f of x is differentiable at x is equal to c, that means f dash of c exists. What is f dash of c in terms of limit? F dash of c can be written as limit x tends to c of f of x minus f of c divided by x minus c exists. So, there is a formula for f dash of x. Limit f dash of c is also equal to limit of x tends to c of f of x minus f of c divided by x minus c. If this exists, then this is said to be f dash of x. That is nothing but f dash of c. Okay. Now here, since if f dash of c exists, that means given that f of x is differentiable at c means f dash of c exists. What is the definition of f dash of c? F dash of c is nothing but limit extends to c of f of x minus f of c divided by x minus c. This we have studied in our first PUC class, that is by the derivative using first principles or by definitions. Now just if you apply the limits for both numerator and denominator, this can be written as limit of f of x minus f of c divided by limit of x minus c. Applying the limit for both numerator and denominator, then this becomes limit f of x minus f of c divided by limit of x minus c. I is equal to f dash of c. Now just cross multiply this. Therefore, limit f of x minus f of c is equal to f dash of c into limit of x tends to c of x minus c. Just cross multiply this. Cross multiply. So, limit f of x minus f of c is equal to f dash of c into limit x tends to c of x minus c. Now, substitute the value of c. Put x is equal to c. What happens? If you put x is equal to c, this becomes c minus c. C minus c is 0. This reduces to 0. That means 0 into any number is 0. The right hand side is totally equal to 0. The right hand side reduces to 0. So that means limit f of x minus f of c is equal to 0. See here, that is limit f of x minus f of c is equal to f dash of c into limit of x minus c. Put x is equal to c. If you put x is equal to c, then this becomes f dash of c. X is nothing but c minus c. C minus c is equal to 0. 0 into any number is equal to 0. So, limit extends to c of f of x minus f of c is equal to 0. That means f of x is a continuous function. Therefore, f of x is continuous at x is equal to c. That is the meaning. Followed. See here. What is the definition? According to the definition, if a function f is differentiable at the point c, then it is continuous at that point. Now, but the converse need not be true. So, let us, given that f of x is a function, let us consider a function f of x which is differentiable at the point c. So, if it is differentiable at the point c means, according to the definition, f dash of c exists. What is f dash of c? F dash of c is nothing but limit extends to c of f of x minus f of c divided by x minus c. So, that is f dash of c is equal to limit of f of x minus f of c divided by x minus c exists. Now, just apply the limit for both numerator and denominator. Limit extends to c of f of x minus f of c divided by limit extends to c of x minus c. Cross multiply. So, that is f dash of c into this denominator. That means numerator limit f of x tends to c of f of x minus f of c is equal to f dash of c into limit x tends to c of x minus c. Now put x is equal to c. If you substitute the value of the limit x is equal to c, then this left hand side remains the same. Limit x tends to c of f of x minus f of c is equal to f dash of c into, put the value of limit, the value of x is equal to c in this limit, c minus c is equal to 0. So 0 into f dash of c is equal to 0. The right hand side is totally equal to 0. Therefore, limit extends to c of f of x minus f of c is equal to 0. That means f of x is continuous at x is equal to c. That is limit, because you can write limit extends to c of f of x is equal to f of c. What is the definition of continuous function? A function f of x is said to be continuous if the left hand limit, right hand limit must be equal and equal to functional value. So, the left hand limit, right hand limit are equal. That is limit extends to c of f of c, and that is also equal to functional value f of c. Therefore, this is a continuous function. Therefore, f of x is a continuous function. That means converse is not true. That is, every continuous function at x is equal to a need not be differentiable at x is equal to. So, every continuous function need not be differentiable at x is equal to a. So, that is regarding the differentiability. Now, let us take the first concept which we are going to study is a differentiation of a function, that is composite function, that is called chain rule. Now, let us come to the differentiability, that is composite function, d by dx of composite function. So, composite functions. Function of a function is a composite function. To differentiate a composite function, we are going to apply the rule that is called the chain rule. Chain rule. What is this d by dx of f of x to the power of n? So d by dx of f of x to the power of n. Suppose y is equal to f of x is a function. F of x to the power is a function. Now differentiate this. D by dx of f of x to the power of n is always equal to n into f of x to the power of n minus 1 into d by dx of f of x. This is the formula we are going to use. D by dx, derivative of f of x to the power of n is equal to n into f of x to the power of n minus 1 into d by dx of f of x. That is d by dx of f of x to the power of n is always equal to n into f of x to the power of n minus 1 into d by dx of that inside function f of x. So this is called derivative of function of a function, that is called composite function. Composite function. Now suppose this can also be called it as a chain rule. Suppose if y is a function of u, let me take if y is a function of u and u is a function of x, then how to write dy by dx can be written as differentiate y with respect to u, dy by du into u with respect to x, du by dx. So this is called your chain rule. Dy by dx is equal to dy by du into du by dx. So that is also called as a differentiation of a function using chain rule or composite differentiation. Okay. Now let us take few problems based on this. Let me take a problem. Now what is the formula? D by dx of f of x to the power of n is always equal to n into f of x to the power of n minus 1 into d by dx of this inside function f of x. Now let us take an example. D by dx of x square plus 3 whole to the power of 4. This is f of x to the power of n. What is f of x? X square plus 3. What is n? N is equal to 4. So this can be written as f of x to the power of n is n into 4 into x square plus 3 whole to the power of 4 minus 1 into d by dx of inside function is x square plus 3. So this can be written as 4 into x square plus 3 whole to the power of 4 minus 1 is 3 into differentiation of x square, you know, 2x, and derivative of a constant is 0. So 2x plus 0 is equal to 2x. 4 into x square plus 3 whole cube into 2x. If you want to multiply, we can multiply 4 into 2 is 8 times x into x square plus 3 whole cube. This is the derivative of x square plus 3 whole to the power of 4. Okay. Let me explain once again. This is f of x. Consider this as x. F of x to the power of n. F of x is x square plus 3. What is the formula? D by dx of f of x to the power of n is n into f of x derivative to the power of n minus 1. That is n into f of x to the power of n minus 1 into d by dx of f of x. So here n is 4 into x square plus 3 whole to the power of 4 minus 1 into d by dx of this inside function x square plus 3. Now this is as it is, 4 minus 1 is 3. Now differentiate, term by term differentiation. Differentiation of x square, this is x square is 2x and differentiation of 3 constant is 0. 2x plus 0 is 2x. Multiply 4 into 3, 4 into 2 is 8x into x square plus 3 whole to the power of 3. Now suppose similarly if I take one more problem, let us consider d by dx of similar type problem. 4 minus 2x whole to the power of minus 3. Now what is f of x here? So let us consider one more problem. Let us take d by dx of 4 minus 2x whole to the power of minus 3. What is f of x? F of x is 4 minus 2x. What is n? N is equal to minus 3. So n is equal to minus 3 into f of x to the power of n minus 1, minus 3 minus 1 into d by dx of this inside function d by dx of 4 minus 2x. Followed? That's it. See here, f of x to the power of n. N is minus 3 into f of x, 4 minus 2x whole raised to minus 3 minus 1 into d by dx of inside function f of x is 4 minus 2x. So this can be written as minus 3 into 4 minus 2x whole to the power of minus 3 minus 1 is minus 4 into You know derivative of constant 0 minus 2 into differentiation of x is 1. So minus 3 into 4 minus 2x to the power of minus 4. 0 minus 2 is minus 2. Multiply this minus into minus plus. 3 2s are 6 times 4 minus 2x whole raised to minus 4. This is the derivative of the function. Followed. Now let us take one more problem. D by dx of, now you know this d by dx of derivative of root x. So d by dx of, let us consider sine root x. So we know what is derivative of root x. D by dx of root x is equal to 1 over 2 root x. Now let us consider d by dx of sine root of sine x. These are all very important problem for 1 more. So let us consider this as root x. Instead of x it is sine x. What is derivative of root x? 1 over 2 root x. Instead of x it is sine x into d by dx of inside function sine x. So this is 1 over 2 root sine x into differentiation of sine x is cos x. So this can be written as cos x divided by 2 times root of sine x. This is the derivative of root of sine x. See here, d by dx of root of sine x. So root of sine x, you know derivative of root x is 1 over 2 root x. Instead of x it is sine x. That's all. Just use sine x in place of x and differentiate again that sine x. That's it. So let us consider this as root x. D by dx of root x is 1 over 2 root x, 1 over 2 root sine x into d by dx of inside function, that is sine x. So differentiation of sine x is cos x. So that is equal to cos x divided by 2 root sine x. Let me take one more similar problem. D by dx of root of tan x. Same type problem. Let us assume this as root x. What is d by dx of root x? D by dx of root x is 1 over 2 root x. So differentiation of root x is 1 over 2 root x into d by dx of inside function, that is tan x. D by dx of tan x. This is equal to 1 over 2 root tan x into differentiation of tan x is secant square x. So the simplified answer for this is secant square x divided by 2 times root of tan x. This is the derivative of root of tan x. Followed. So just assume this as root x. Inside root, instead of x it is tan x. Differentiate tan x separately. That will give the answer. That is called, this type of differentiation is called a derivative of a composite function, that is a d by dx of a function of a function. Now take one more example. Suppose if it is d by dx of sine of root x. Sine of root x. Now here this can be written as, consider this as x. You know what is the formula for sine x? Sine x is equal to differentiation of sine x is cos x. So this can be written as sine x, differentiation of sine x is cos root x into d by dx of root x. So this is cos root x into derivative of root x is 1 over 2 root x. This is equal to cos root x divided by 2 root x. This is the simplified answer. Please listen to me here. Now this is d by dx of sine root x. D by dx of sine root x means, let us consider this as sine x. Sine x. What is d by dx of sine x? Cos x. Instead of x we have root x. So d by dx of sine x is cos x. Instead of x put root x into d by dx of root x. Differentiate root x again. Cos root x into differentiation of root x is 1 over 2 root x. This is cos root x divided by 2 root x. Or similarly, if you take one more problem, d by dx of, let me take secant root x. Secant root x, same formula. What is d by dx of secant x? We know the derivative of secant x is secant x into tan x. So consider this as x. Instead of x it is root x. Now differentiation of secant x is secant root x into tan root x into d by dx of root x. Okay, see here, instead of x, here it is root x. Just represent this as x. D by dx of secant root x is secant root x into tan root x into d by dx of root x. Now this can be written as secant root x into tan root x into derivative of root x is 1 over 2 root x. 1 over 2 root x. That's how we are going to differentiate. Just assume that the given function as the standard functions, then differentiate, you will get the answer. Now let us take few more problems based on this. Now let us consider if y is equal to sine of x square, find dy by dx. So usually you will get this type of problems for 1 marks. So if y is equal to sine of x square, find dy by dx. Differentiate this. Differentiating with respect to x. So what we will get? Dy by dx is equal to d by dx of sine of x square. Now let us assume this as u or x. So differentiation of sine x is cos, instead of u it is x square into d by dx of x square. That's it. So this is cos of x square into differentiation of x square is 2x. So the derivative of sine x square is cos of x square into 2x. See here, differentiating with respect to x, d by dx of sine of x square. Differentiation of sine x is cos x. Instead of x, we have x square into differentiate x square separately. D by dx of x square is 2x. So the answer is cos x square into 2x or 2x into cos x square. Let me take one more problem like this. Yeah, d by dx of tan x cube. So here, instead of tan x, it is tan x cube. Differentiation of tan, you know, d by dx of tan is secant square x cube into d by dx of x cube. So this is secant square x cube into differentiation of x cube is 3x square. Now, so this is, call it as x. Listen, d by dx of tan x is equal to secant square x. Instead of x, it is x cube. Again differentiate x cube, d by dx of x cube is equal to 3x square. Let me take one more problem. D by dx of e to the power of root x. Since you know what is d by dx of e to the power of x, e to the power of x is e raised to x itself. Instead of x, it is root x. So d by dx of e to the power of root x is e raised to root x into differentiate this root x again. So this is equal to e to the power of root x into differentiation of root x is 1 over 2 root x. 1 over 2 root x. Okay. Now let me take one more problem. So d by dx of sine of x plus 3. Now let us consider this as x. Now differentiation of sine is cos x plus 3 into d by dx of x plus 3. Now what is this equal to? Cos x plus 3 into differentiation of x is 1 and 3 constant 0. So d by dx of sine x plus 3 into x plus 3 is nothing but cos x plus 3. That's it. So these are the few simple examples for derivatives of a composite function, that is function of a function. So we will discuss a few more problems, complicated problems on these compositions of functions in the next class. Thank you very much. Thank you.